Today I will present briefly the activity we are promoting within the EERA, European Energy Research Alliance Joint Program Energy Storage, and in particular the storage project supporting the hybrid energy storage solutions for the clean energy transition. I'm a researcher at CNR, Institute for Advanced Energy Technology, and at the same time I'm a representative of CNR at the EERA Energy Storage, and I'm in charge, co-chair of the ST6, of program 6 on energy storage technologies, mainly on techno-economic and sustainability assessment of energy storage technology. What we learned in this last year that the European Commission is pushing to reach the 100% renewable energy system in Europe with different policy packages promoting the clean energy, so-called clean energy transition, dealing with climate change, security of supply, circular economy, and resiliency. To achieve this, the energy infrastructures, all energy infrastructures, heating and cooling networks, electric grid, power grid, gas grid, have to be highly flexible. So they need storage to reach the goals of 100% renewable energy. Sorry, too fast. So within the EERA JP energy storage, we highlighted our activities to promoting the hybrid energy storage solution because just there is no silver bullet. There is no one technology can cover all the needs. No single technologies can support the clean energy transition. A lot of experience and concept has been promoted in the scientific area. And now in this slide we can see which kind of hybrid energy storage has been taken into account in our scientific paper, but more increasingly interesting commercial aspects and new business cases are coming out to reach the final goal. The hybrid energy storage mainly started to help batteries to reach targets in terms of cost, in terms of durability, lifetime, and the most studied hybridization is a supercapacitor helping batteries in order to have a stable working conditions and to have a long life, either long life. But a lot of hybrid energy storage technologies combining the long-term energy storage and short-term energy storage is approaching in the last years. So matching renewable generation, in order to match renewable generation intermittency in the power grid, and also the rapid growth of the electric hybrid vehicle technology opens a new era of energy storage systems. So, EERA is promoting hybrid energy storage system with two main actions. An input paper for the Clean Energy Transition Partnership, contributing to the definition of the strategic research innovation agenda of the Clean Energy Transition Partnership. We pushed a lot on hybrid energy storage solutions, highlighting the importance to have hybrid systems. And finally, the storage project that I will introduce you today. So the energy storage technologies are different in terms of cost and technical properties. You perfectly know that different kind of energy storage solutions that can provide power peaks, or they can provide capacity in terms of energy storage and minimizing the cost. But hybridization aims to reduce environmental impact. Combining different energy storage technologies, hybrid energy storage can adopt technology with lower impact, among them with already well-established recycling process, guaranteeing the same performance of lithium-ion batteries, for instance. Hybridization helps also to overcome critical raw material constraints reduce social impact, and foster EU supply chain. This combines different battery energy storage technologies. The hybrid energy storage solution can compete with the single technologies that use critical raw materials. So these two aspects are really relevant for the clean energy transition. The second aspect is that several application fields and multiple technologies are available to fulfill the requirements, for instance, of the power grid. And there is a lot of services that energy storage must provide to the power grid. So stacking of services, aggregation of complementary benefits of the different energy storage technologies through the provision of multiple services might outweigh costs. So we can stack different services in order to reach in early stages, early as possible, the economical suitability and viability of the energy storage system. So which are the research needs we highlighted? So hybrid energy storage solution system is considered to be a favorable solution in the future in various complications. But further research and development should be conducted to demonstrate their feasibility and advance their functionality. So we need further research to develop a stable and cost-effective hybrid energy storage solution. So power electronics and control strategy has to be developed to harmonize the hybrid energy storage features. So the core of the activities of the power electronics and control strategy. But in particular, we need business cases. We need demo because we have seen that we have experienced that the volatility of electricity prices of different regulations in different countries are not so helpful for the energy storage in general and the energy storage solution in particular. So market design is really, really important. So what we can see that we need an holistic approach. We need very complex projects within Europe in order to sustain energy storage, and in particular hybrid energy storage as a solution to overcome problems regarding environmental aspects, social aspects, and cost. So within the activities of the EERA energy storage, we promoted and now is running the storage project. The storage research infrastructure ecosystem that aims to create an ecosystem supporting the activities, the research activities on this field. The main objective is to foster European ecosystem of industry and research organization mainly on hybrid energy storage technologies, to provide access to world-class materials and energy storage related research infrastructure, enlarge and advance the integration of the European energy storage community, so supporting also the European Commission with the strategic research and innovation agenda, with white papers, with supporting documents and studies, business case studies, environmental and social aspect studies. Enhance innovation by involving industry experts in early stages in order to design new codes and new activities for to find out focal points in terms of research. Ensure the long-term sustainability of the energy storage research by defining scenarios and strategic roadmaps, by setting up a framework for scientific and technical training for young researchers. One of the main pillars is to create new professional figures in the energy storage sector. And promote and coordinate international cooperation in energy storage research from end to Europe. So the energy storage ecosystem within the storage project is composed by 47 beneficiaries, 74 research infrastructures covering all the aspects of the research, from materials up to systems, including also overarching activities. So there is also important to bring people from outside, also from outside Europe, outside the core group, and all of you are invited to join the ecosystem to increase the community. The main outcomes, we will have 6 transnational access calls to the research infrastructure. The project covers the cost of the tests performed in in the research infrastructure selected by the applicant. We are going to develop a materials acceleration platform for energy storage using for instance, high-performance computing from ENI, for instance, or using infrastructure in Canada, in Germany. We have created also a network on an acceleration platform for new materials. Defining a roadmap for hybridization of energy storage to define which is the process that to allow which is the most feasible use cases in terms of economical, social, environmental point of view. We will provide also to the European Commission and to the community a strategic research innovation agenda and a white paper on energy storage, hybrid energy storage. We're starting with an international mobility scheme supporting PhD students across Europe, university master program on hybridization energy storage, and 3 summer schools, so promoting the creation of new expertise in this field. In the work package 1, there are 3 working groups open to all the community energy storage, mainly to the definition of the roadmap of EERA, to the transnational access to research infrastructure core topics. So the definition of the core topic is an open process. Also to digest the transnational access results using open data coming from the research infrastructure access, and also to highlight which are the barriers, technical and non-technical barriers to be overcome in the next year. So today, more than 100 stakeholders are involved in definition of the gaps, standardization challenges, roadmap and clear definition, transnational access goal definition, and analysis of the transnational access results. So if you are interested, please contact us. I will now give you more information how to assess the code, and which is the first theme of the first topic of the first code. So we can briefly it's an increasing network day by day, composed by industrial industries and also research organization and universities. So the working group 1 is the main focus of these activities, the ecosystem of the storage project. Are all the stakeholders. Why you have the opportunity to give your feedback statement to the roadmap at EERA to be adopted in the final document. And we will organize 2-3 workshops per year in order to receive feedback. And how to join is by signing a letter of intent. So you will be a member of the storage ecosystem. So the roadmap and the 3 are the main documents, so will give us, based on studies performed within the storage project by partners and stakeholders, will highlight which are the main processes to reach the feasibility of the hybrid energy storage technology. So the first step we have to face is the definition of hybridization. There is not a clear definition of hybridization worldwide, so the main discussion of the first step, the main discussion was the definition of hybridization. And this is a statement we wrote during our first meeting. So hybridization of energy storage refers to the utilization of 2 or more energy storage technologies together or either a system, device or materials level to provide technical and economical advantage beyond what any single energy storage technology can provide. Also considering the sustainability and reliability of the lifetime of the hybridized solution. So the sustainability assessment of the hybrid energy storage technology is a central point. So we defined the different levels of hybridization and also the mechanism of hybridization. So hardwired integration, software-wired integration, and software integration. So this is a very wide definition that can bring together all the definitions of the hybrid energy storage solutions. So we defined also the structure of the guideline document to finalize the TRIA and the white paper and the roadmap. We will use data from the TMA calls to the access to research infrastructure, also to feed the process in order to have use cases, business cases, environmental and social aspects, taking into account also these aspects in the stream, and defining which are the key aspects that we have to foster in the next year. So what is a transactional access? So everyone can have access to the lab with the best research infrastructure selected during the submission phase of the project, offering for the first time for free. So the costs are covered by the project itself. And if you apply for storage, if you go to another country, you cannot apply for your country or you are obliged for EU regulation, but you can apply for research infrastructure whether in Europe but not in your country. The selection of the application will be done through the evaluation process thanks to experts that on a voluntary basis will be engaged. We have also already a list, a very populated list of experts, but it's open. You are welcome to be engaged also in this process within the storage project. So the first call is application-oriented architect sustainable energy storage solution. It's very wide, the first call, it's very broad, because it is the first attempt, so we would like to be receive feedback application from the energy storage community. The first call we will close now in July, but we will have 2 calls per year, so don't worry that there will be opportunity to access to the research infrastructure. Who can apply? Academia and industry entities from EU members and associated members. And in the storage project website, you can find all the documentation. It's very easy to submit. It's not an application for European project. It's very easy. Also to be on time respect the deadlines we have. All Europe is covered, all fields are covered, so 64 research infrastructures covering all the energy storage sector area, and the major part of the laboratories are already hybrid laboratories because cover more than one technology, more than one area. So there is a clear plan for the course, so you can prepare application and when you prepare, participate also to the code definition, so you can be part of the process. There is also international research exchange calls with Canada, also within the European Union members. So thank you for your attention. If you have any question, I'm available to